This is problem number 1 from section 1.5. In this problem it says sketch the given curves together in the appropriate coordinate plane and label each curve with its equation. They give us 4 different exponentials and they want us to graph each of these. I'm going to use the TI-84 to do this graphing piece, and I'm going to do each equation individually, kind of one at a time, and then we can compare them all together. So start by saying y equals, and just make sure you clear out your equations that you already have in there, and we're going to say 4 to the x power. And then I'm going to graph that. Alright, and then I got to check my viewing window here. We better make sure we're at negative 10, 10, 1, negative 10, 10, 1. Make sure that the graph comes out how we think it should look. And actually, I'm going to change that window to negative 5, 5, 1, negative 5, 5, 1. I think that's going to make it so that we can see this a little bit better. So for this exponential, this is y equals 4 to the x power, right? So this blue is y equals 4 to the x power. I'm going to kind of label these with some different colors as we go. So I'll just say that this is the blue one. And then we're going to graph the next one red. And then I believe, let's see, if we go to y equals, it'll be blue, red, black, purple. All right, let's look at this graph here. So any exponential is going to go through the value of 1 every single time. So anytime you have an exponential, it goes through the value of 1. Unless, of course, you have a shift on that exponential. But if it's just the parent function for an exponential, it goes through 1, because if I plug in 0 for x, for any of these exponentials, I get 1, right? Because any base to the 0 power is 1. So a normal exponential will start and get really close to 0 on the left side as it gets close to negative infinity, and then it's going to bend upwards going through 1 on the y-axis, and then bending upwards quickly after that. So let's graph y equals 5x, see what the difference is. So 5 to the x power. We'll graph them both, and you should see that the red line, you can see it increasing quicker. If you see the little difference, the little gap there, the red line is increasing quicker. So that means that because this base is larger, it's going up faster for every x value you plug in. Now, what's going to happen if we have a negative exponent? Well, if you made a chart for the negative, for 4 to the negative x, let's just make a little chart here. And this is for 4 to the negative x, so y equals 4 to the negative x. And let's plug in like negative 2, negative 1, 0, 1, 2. When you plug in negative 2, you'll get negative 2, which is just positive 2, so you end up with 4 squared, which is 16. Plug in the negative 1, you end up with 4 to the first, which is 4. 0, you get 1. 1, you're going to get 1/4. And 2, you're going to get 1/16, right? Because 4 to the negative 2. So as you can see, that as the x values increase, we're getting closer and closer to 0. This is going to be a reflection across the y-axis, so let's take a look at that. We're going to have y equals 4 to the negative x. Go ahead and graph that, and you should see a reflection across the y-axis, that black line there. So it's the exact opposite of 4 to the x, so we can say that those are opposite. And finally, let's graph y equals 1/3 to the x power. Deleted that on accident. And we want fraction 1/3. Let's put that to the x power. And you should see reflection for this 1/3 to the x power as well. So you got your blue line, which is y equals 4 to the x. Then you got your red line, which is y equals 5 to the x. Now you've got your black line coming in, which is y equals 4 to the negative x, right? Or reflection across the y-axis. And then anytime you have a value for your base that is less than 1, so if the value for your base is less than 1, you are also going to have a reflection across the y-axis. And you can see that there with the pink line. So if we have a negative for an exponent, or we have a value that's less than 1, we're going to have a reflection across the y-axis. Now I do want to show one more that's not written in here. What if we have y equals -4 to the x power? So let's go ahead and put that in there. -4 to the x power. And you can see that this is now reflected across the x-axis. So anytime you put a negative in front, that's going to be reflecting across the x-axis versus reflecting across the y-axis there. So I hope that makes sense.